Welcome back, college personal finance students. This is Mr. Clem, and we are going to go over the answers to some of the homework that we've been practicing, some of our time value of money ideas. In class, we talked about doing the calculation for simple interest the long way. We've done compound interest the long way, the PRT, principal rate time way. And we're also going to look at doing time value of money using the future value function. So our first problem here, we started this as a group today. Here's our story. Max Clement earned $4,000 this past summer, and he wants to use it as a down payment for a car when he graduates from high school. The assumption is he's a junior. When he graduates from high school, that's going to be 2 years down the road. So one of the facts we know is $4,000. One of the facts we know as far as time, how long, is going to be 2 years. And he has several options. He's got a money market account that will give him interest every quarter or compounded quarterly at 3.75% interest. Another option is a certificate of deposit that's going to give him more interest, 4.25%, but it's only going to be compounded every 6 months or semi-annually. He can borrow it to his friend Bob, and Bob will pay simple interest of 3.95%. He can borrow it to me, and I'll pay him compound interest monthly, but I'm only going to pay it 3.15%. So 4 options. Which one is the best option? Which one is going to give him the most bang for his buck so that he has the most amount of money to go buy this vehicle? As we look at a spreadsheet here, I do it both the long way, the principal times rate times time way, and then I also do it the future value way. So we start here again with our facts. We got $4,000 that we're depositing, and we're leaving it in there for 2 years. So here is option A, money market account, 3.75% interest. It's compounded quarterly. So we start with principal. We've got rate. Our time is the how often. And we calculate earning $37.50 in interest. Now that $37.50 gets added to the $4,000 in principal, and starting in month 4, we've got $4,037.50. Since our principal got bigger, the logic is our interest got bigger. And we just keep leaving the money in the account, and it keeps growing and it keeps growing. Over here on the far right-hand side, we have to figure out how many times do we need to do our math in total. Well, if it's compounded quarterly, that's 4 times in 1 year, that's 4 times in another year. So we've got to do that math a total of 8 times. Now, this 8th calculation, the key is we need to bring our math down one more time because we have $4,270. We earned another $40.03. 43.10.03 is going to be our final answer. Again, principal times rate times time. This is the long way of doing it. Here is our future value function. Now, our future value function is going to have 5 pieces, and we talked about that earlier today. It's going to have the function equals future value. Inside the parentheses, here are our 5 pieces of information. Our interest rate, right? And that interest rate is usually started or stated as an annual rate. And then if it is not an annual rate, we would have to make some adjustments to that. Multiply it by a certain number if it is simple interest over multiple years, or multiply it by a fraction or divide it if it's going to be more often than once a year. N per is going to be the total number of times we do our math. So again, the problem we dealt with said we're going to do this math 8 times. Payment, or the PMT part of our function, is are we going to leave all of the money in there? Are we going to take the money out, or are we going to make additional deposits? We're just dropping in the one chunk of $4,000, so there's no additional deposits going in, and that's why PMT doesn't have a value. It's 0. Present value is going to be the type of money we have. How much money are we depositing? Again, in our example, it's $4,000. And type tells us, are we going to get this calculated at the end or the beginning? This doesn't have a lot to do with simple compound interest. It's more often used when we start looking at annuities, both ordinary and annuities due. Are we going to deposit the money at the beginning and then earn a year's worth of interest, or are we going to wait a year and then deposit and then earn interest? Right? So type is going to be 0. PMT is going to be 0 for most of our calculations that we work on in this class. In more advanced situations may be different. So here's our formula. Equals future value, open it up. 3.75%, and then I chose to divide it by 4. If I multiplied it by 0.25, it would get the same thing. Take my annual interest rate and turn it into a quarterly number, comma. The commas separate our ideas. Now, N per, how many times am I doing my math? Well, I did that math a total of 8 times, comma. Am I putting any more money in? Am I letting any of it leak out? Nope, so payment's going to be 0. My present value, I choose to go with a negative 4,000, like I'm taking money out of my pocket and giving it to the bank. That'll in turn give us an answer with a positive number. And then my type is 0. So equals future value, interest rate, adjusted for time. How many total times is the math done? All in one formula. Payment, present value, and 0. And you notice that I get the same answer whether I do it the old school long way or I do it the new school, if you will, future value way. Well, what's our second problem? Let's practice that some more. Same $4,000, still leaving it in for 4 years. However, we're getting 4.25% interest, and it's compounded every 6 months. 2 calculations in the first year, 2 calculations in the second year. Total of 4 times. So here is our long way. 4,000, 4.25% interest. Time is calculated earning interest every 6 months. We earned $85 in that first 6 months. Add that $85 to the principal, do it again. It makes sense that this number grows. Now we can ballpark it and say, well, it grew by almost $2. So the jump from here to here should be about $2, maybe a little more. It shouldn't be $868.10 or $8.68, right? We should be able to kind of give it the old smell test. And does that make sense in how it's calculating our math? Answer here, $43.50.99. Go ahead and do the future value way. Again, our 4.25% annual interest rate, adjusted for time, divided by 2, or multiply it by 0.5, gets you the same answer. Comma, how many times did we do math? Well, we did it 4 total times, so N per is 4. 0, we're going negative 4,000, so our answer spits out positive. So right now of our 2, 43.10 versus 43.50. Right now the CD is a better option, partly because the interest rate is so much bigger than the money market. Option C, borrow it to your friend Bob, and Bob's going to pay you 3.95% simple interest. So $4,000, 3.95% interest, and our time is going to be more than 1 year, so it's going to be the whole number 2 because we're leaving it in for 2 years. We get $316 in interest, so we end up with $43.16. Here is where we look at future value. And this is one of the keys of using the future value function as it pertains to simple interest. N per is always the number of times you did math. It was 4 times on this problem. It was 8 times on this problem. We did math 1 time. So the N per here has to be 1. Well, how do we make the 1 year's worth of interest be different because we can only do the math one time? Well, because this is more than 1 year, we're going to multiply 3.95% interest by the whole number 2. That takes my rate and adjusts it for my time. Why? Because we're only doing this math one time. 0 on the payment, 0 on the type, negative 4,000. Same $4,316. Last one here, you borrowed it to Dad, that's me. It was compounded monthly, but only at 3.15% interest. So we're going to do this math 12 times in the first year, 12 times in the second year. We got to do this math a total of 24 times. Still start with 4,000. 3.15% interest is our interest rate, and time is 1 divided by 12, or 0.083333333333333333. It's not 0.08. If it's 0.08, you're going to have some rounding errors, and your math is not going to jive with what Mr. Clem's got going on. I earned about $10. It then grew an additional 3 cents. So again, the long way of how does this formula come up with the answer it does. Well, here's the long version. 10.50, then 10.53, and it's growing by about 2 to 3 cents per until it gets all the way up to about $11 in interest. My answer, I get back a total of $4,259.76. I write my future value formula, same thing, 3.15 divided by 12, because I'm doing this monthly, comma, how many times did I do it? I did this math a total of 24 times. Payment 0, negative 4,000, and 0. That'll conclude our video here. We'll look at each practice problem as its own video. If not, these could get really long. Have a good day.